So the last thing I want to talk about in this section is how to find integrals of the products of the sine and cosine, where instead of just being sine of x and cosine of x, you have multiples of x. For example, the integral of the sine of 5x times the cosine of 3x. Well, to do that, we're going to use these trigonometry formulas. Now, I will admit to you, when I teach trigonometry, by the time we get to these formulas, they already have a page full of these things in front of them. And from a trigonometry perspective, these formulas are just weird. They're just not super useful for any of the applications we talk about in trigonometry. This is why they get mentioned, is so that you've seen them before when we finally get to this section in second semester calculus, and they really are going to be useful. Hopefully in a way that just looking at them is pretty obvious to you. They let us change this product of two functions into the sum or difference of two functions. And once we've got just a cosine or just a sine, those we can integrate pretty easily. So I've got an example for us to look at here. And all I'm going to do is use I think it was the third identity from the previous page to rewrite this. And then the integral itself will actually be pretty straightforward. So this is I'm going to put the 1/2 out in front. 1/2 integral sine of 5 minus 3x plus the sine of 5 plus 3x dx. All right, so let's just do the arithmetic. So 1/2 integral sine of 2x plus sine of 8x dx, which now we can actually do the integrals. 1/2 times, this will be minus 1/2 cosine 2x minus 1/8 cosine 8x plus a constant. And that's really it. I'll go ahead and distribute the 1/2. That makes it a little cleaner. This is minus 1/4 cosine 2x minus 1, whoops, not 8th, minus 1/16 cosine 8x plus a constant. And that's it. That really is all there is to doing this particular type of integral. Okay, so where are we going next? We're going to look at another kind of integral that again, involves trigonometry, right? But this time we're going to look at what are called trigonometric substitutions. Right? We're going to look at ways that by letting, for example, u equal the sine of x, we can simplify an integral, simplify an integrand to the point where we can figure out what its integral is.